Example number 5 says suppose that the price of pork P depends on the supply S by the formula P is equal to 160 minus 3S plus 0.01 S squared. It says find the rate of change of P with respect to S when S is equal to 50. So what we need is the rate of change of P with respect to S is given by dP ds, which is the same thing as P prime of S. Now they didn't specifically write up here P of S, but S is the variable on this side, so we could write this as P of S. That's an S in there. Okay, so this is what we need to find, and we need to specifically evaluate it when S is 50. So we need dP ds at 50, or another way of writing that is we need P prime at 50. We need the rate of change of P with respect to S at 50. So dP ds is the derivative of this guy. Derivative of 160 is 0. Derivative of negative 3s is negative 3. And the derivative of 0.01 s squared is 2 times 0.01 times s. And that gives us negative 3 plus 0.02 s. Now we need to evaluate that when s is 50. So we'll take dP ds at 50, and that's going to be equal to negative 3, oops, we don't want that in there, plus 0.02 times 50. So this is negative 3 plus 0.02 times 50 is 1. And so it'll be negative 3 plus 1, which is negative 2. So the price, the change in price with respect to the supply is negative 2 at 50, which tells us that an increase in S, if we increase the supply by 1 unit, okay, we'll see a rough decrease. It's not going to be exactly negative 2, but a very close decrease in price by 2 units. Now the reason I say it's not exact is because that would be what our actual change is. This is just the instantaneous change, and this is over an interval. Okay, but it gives us a good idea of what's going on at that specific value.